We're in Algebra 2 at 10.2b, and we're going to talk about equations of circles, and I have a couple theorems for you. We have 3 previous videos for Chapter 10 now. You can click on the description if you become lost or confused and watch those to catch up. We can find the equation of a circle if we know the coordinates of the center and the radius. Some equations of second degree have graphs that are circles. So we've talked about lines on a graph, we've talked about parabolas on a graph. Now we've got circles on a graph. So here's our definition. A circle is a set of all points in a plane that are at a constant distance, the radius, from a fixed point in that plane. And that fixed point is the center of the circle. So it's the set of all points in a plane that are a constant distance from that center point, okay? And that distance is the radius. So remember, the center of a circle is not part of the circle, it's just the center of it. And remember that we take the square root to get the radius. We do r squared, don't we? So we first consider an equation for a circle centered at the origin. So we're going to talk about what happens when the circle is centered at the origin and when it's centered anywhere on the coordinate plane, okay? So this is for the origin. Here's our theorem. The equation in standard form of the circle centered at the origin with radius r is x² + y² = r². We can find an equation of a circle with center at 0, 0, and a radius of the square root of 5 using the standard form of the equation for a circle centered at the origin, this equation. We put in our square root of 5 for r², and we get the square root of 5 times 5, which is the square root of 25, which equals 5. So x² + y² would equal 5. Okay? Examining an equation for a circle with its center anywhere in the coordinate plane. Here's our theorem. The equation in standard form of a circle with its center hk, and the radius r is the square of x minus h plus the square of y minus k equals r². So we can find an equation of a circle with its center at a -1, 3 for our h and k values, and a radius of square root of 2. We substitute in our h and our k into the equation. We're adding the opposite here, so we get a +1. And the square root of the square root of 2 is square root of 2 times 2, which is a 4, which equals 2, right? All right, so now let's try this one. Here's our h value, and here's our k value, and our radius is 2 times the square root of 7. We'll put in our -2 for our h value, our -6 for our k value. We're going to add the opposite here and get a +2. We're going to add the opposite here and get a +6. And 2 times the square root of 7 squared is 4. We multiply the coefficients times the square of 49. And the square of 49 is a 7. So that means we have 4 times 7, which is a 28. That wasn't that hard, was it? So if the center is the origin, we're going to use this. And if the center is anywhere on the coordinate plane, we're going to use this, okay? So this is what you need to write in your notes. And that's with radius r, okay? Now, just for fun, get a flashlight. And on a flat surface, a plane, see the different patterns made by that flashlight beam. Depending on the angle that you aim the flashlight, you're going to get beams that are circular, ellipsoidal, parabolic, or hyperbolic. And they'll change depending on the angle. Isn't that cool? Our next video is 10.2c. We're going to find the center and radius of a circle from an equation. I'm going to add this video to the Algebra 2 playlist, and there's going to be links to those 3 previous videos for this chapter, Chapter 10. And of course, I always have a link to the Algebra 2 playlist in there too, don't I? And I hope you're doing great. I hope you're understanding all of this. If you liked this video and it helped you, hit the like button and share it with your friends. I'll see you next video. Bye.